Acha. Now we will be studying a electric device which is called simple DC motor. So this is simple DC motor is used in our houses in electric pump, okay, mixer grinder, all places we are using simple DC motor. So this uses the principle of electromagnetism, nothing else. Same principle that we have studied right now. This device converts electrical energy to mechanical energy. Just before this we have studied what? That if a moving charge, that is a conductor, is carrying some electricity and it is put into magnetic field, it will experience some force. So suppose I have started one current flow with this plug and bought one wire, made one circuit like this. This is the circuit, closed circuit. If you take this complete coil, this is a closed circuit. Now I put this circuit inside a magnetic field, north to south, magnetic field will start flowing, okay. Then and there definitely this conductor, this coil is going to experience force, the Lorentz force. So as soon as it experiences force, that means electrical energy is getting converted to mechanical energy. Force means mechanical energy, it is going to move. Movement, mechanical energy, ultimately it is going to have rotational movement, which we are going to study. Ultimately it is going to have rotational movement, which we are going to study. But at this moment let us understand the structure, total structure of DC motor. So how do we, in a simplified diagram, how does DC motor look like? So if you say this is the north pole of a horseshoe magnet, this is the south pole of a horseshoe electromagnet. Electromagnet is used because we need to have more energy. You cannot use a normal permanent magnet over here, you have to use electromagnet, okay? So you are using electromagnet. Now there is a coiling, so you know very well about solenoid, we have discussed in the last class. Solenoid korecho na, electromagnet, solenoid. In that solenoid what happens? We have a soft iron core in between coiling. So this is the soft iron core in between the coil, which in this case is called armature coil, okay. There is an axle over here. So basically what happens, this total coil is rotating, which we will understand what is the mechanism of rotating, why it rotates, how it rotates. So when this rotates, definitely the axle will rotate. So as soon as this axle is rotating, I am just installing a pump along with this axle. Pump is nothing, a fan. For you guys, pump is a fan. So I am taking that fan, and or you can take a cycle tire ring. So you can install it over here. As soon as this will rotate, the cycle will also rotate. So ultimately what you are doing? You are transferring electrical energy to mechanical energy. So that is the work of a DC motor, transferring electrical energy to mechanical energy. So see, now there are 2 or 3 things that you need to remember at this moment, later on you will understand. There is a structure that is called S1, S2, which is nothing but split ring commutator. This split ring commutator is basically fixed with this coil, okay. So if this coil rotates, then split ring commutator also will rotate. Suppose this coil is rotating total 180 degrees. So this part will come this side and this part will come this side. Then this S1 will go this side, S2 will go this side. Clear? Correct na? Prashun. And this B1 and B2 are carbon made brushes, but these are not connected with this split ring. It is not fixed with the split ring. It is fixed with the wire. So when this rotates, this doesn't rotate. Wire remains as it is. Only the coil rotates. Okay? So if you see, whenever this coil is going to rotate, this split ring will also going to rotate, and accordingly its function is to reverse the current. Later on we will see how it reverses the current. Reverse the current when the coil rotates. When the coil rotates, it will reverse the current. I will give you an idea. Suppose if the coil has rotated this side, so that time the current direction inside the coil will also rotate, will also change, it will reverse. It will reverse. It is not going to change, it is going to reverse. Because suppose is this is AB. So at this moment current is going to flow like this, AB. So this way, correct? But this AB will come this side. Who is helping to make this AB come this side? Split ring commutator. When this AB comes this side, definitely the current direction will not be at the top, it will come down. Has to. It will come down. So the direction of current can change or will change if you rotate the coil. And who will rotate the coil? The combination of electricity and magnetism, and hence the chapter's name is electromagnetism. ठीक है?